Two charts, both true. One says bees are collapsing, but the other says everything's fine. So which one do you believe? Because the answer reveals one of the easiest ways data can mislead us.
Breaking news.
Welcome to Learn Data Easy. This is the series where we break down data, AI, and cloud concepts without jargon and without stress. I'm Charlene. I work in data and AI, and today we're going to investigate what the data is really telling us about the bee crisis, and more importantly, what it's hiding. So this story starts with something you've probably heard about. Honeybees disappearing, entire colonies collapsing, worker bees just vanishing from hives. And this isn't just about bees. Around 1/3 of global food production depends on pollinators like bees. In the United States alone, honeybees contribute an estimated $15 billion a year to crop production. And this isn't just an American issue. In Europe, pollinators contribute an estimated 15 billion euros annually to agricultural production. So this is a real problem, and naturally, researchers started asking what's killing them. For years, one suspect dominated the conversation: pesticides, specifically a class called, let's see if I can pronounce it correctly, neonicotinoids. So we pulled bee loss data from the Bee Informed Partnership and pesticide use data from the US Geological Survey. And at first glance, this chart looks very convincing. As pesticide use goes up, bee losses also go up. The two lines seem connected. And this is what data scientists call correlation, when two variables move together. And emotionally, this feels like proof. You look at this and think, yep, we found the problem. And mathematically, the relationship looks convincing too. But there's a problem. Correlation does not tell you why something is happening. It only tells you things are moving together. And sometimes that can completely fool you. So while everyone was focused on pesticides, another trend was happening at exactly the same time. Global temperatures were rising too. So we added temperature data from NASA, and suddenly everything is rising together. Pesticides, bee losses, temperature. And now the story becomes much messier. Because when multiple variables trend upward over time, they can look connected, even when the relationship is weak or misleading. A simple way to remember this is this. So imagine ice cream sales and drowning deaths. They rise together every summer. But ice cream doesn't cause drowning. Hot weather increases both. And this is something called a spurious correlation. And this is where data analysis becomes dangerous. Because charts can feel emotionally convincing, even when the logic underneath is incomplete. Because until this point, we've been obsessed with what was killing bees, but we weren't really asking what's happening to the total population. So the top chart looks terrifying. Huge annual losses, 40%, 50%. But then look at the bottom chart. The total number of managed honeybee colonies in the United States is, well, relatively stable. And that creates a massive contradiction because both charts are true. And that is the real data lesson. Our number can make everything look healthy, while the reality underneath is falling apart. So the colony numbers aren't stable because bees are thriving. They're stable because humans are working non-stop to replace losses. Beekeepers split colonies, breed new queens, replace hives, constantly rebuild. And the system survives because enormous effort is being poured into keeping it alive. And this happens everywhere in data. A dashboard metric can look perfectly stable while the system underneath is under extreme stress. And revenue might look stable, but the acquisition costs are exploding. And servers, they might stay online, but engineers are firefighting every night. Support tickets look manageable, but staff burnout is skyrocketing. The top line number hides the operational pain underneath. If you're finding this useful, subscribe. It really helps the channel. And let's keep going, because the data has one more surprise. So we went one step further. We removed the shared time trend mathematically. Basically asking, if we strip away the fact that everything changes over time, does the pesticide relationship still look strong? And once we did that, the relationship weakened dramatically. Now, that doesn't prove pesticides are harmless, not at all. The evidence actually points to multiple overlapping pressures: pesticide, habitat loss, parasites like virus mites, disease, climate change, nutritional stress. So this is not a single variable problem. It's a system under pressure from every direction. But it does show how easy it is for time-based trends to create misleading stories in your data. So let's recap the key ideas. First, correlation just means two things move together. It does not mean that one causes the other. Second, when multiple trends rise over time, they can look connected even when they're not. And this is something called spurious correlation. Remember that one. And the third, a stable top-line number can hide enormous stress underneath. The bees weren't fine. Humans were just working incredibly hard to stop collapse. And if you understand these ideas, you've already built a much stronger foundation for reading data more critically. And honestly, that's the biggest lesson from the whole investigation. The most dangerous dashboards are sometimes the ones that look stable, because stability can hide enormous effort underneath. In a world drowning in charts and metrics, the most important skill isn't finding answers. It's learning to ask, what might this number be hiding? If this has helped, subscribe, and let's keep learning data the easy way. See you next time.